Hello there, and welcome to the Dozing Explorer. I am so glad you found your way here tonight, to this quiet place of rest. Settle in and let the sounds of your day simply drift away like distant clouds on a quiet horizon. Tonight, we have a very special journey planned. We are going to drift to wander far beyond the familiar blue and white of our own sky, far beyond the planets we know by name, and even beyond the shimmering, dusty band of our own Milky Way. We are setting a gentle course for the deep, deep quiet of intergalactic space. On a soft current of thought, we will travel towards our nearest and most magnificent galactic neighbor, the Andromeda Galaxy. It's a place of almost unimaginable scale, a silent, shimmering island of light floating in the vast, dark ocean of the cosmos. For thousands of years, humans have looked up and seen it as a faint, fuzzy smudge in the constellation of Andromeda, a tiny, whispered secret in the night sky, a cloud of light whose true nature was a mystery. But tonight, we'll drift closer. We won't be traveling with speed. There is no rush. We will be traveling with wonder, moving gently through its vast spiral arms, drifting past stars older than our own sun, and contemplating the sheer, peaceful emptiness that lies between them. This is not a lesson. There will be no test. It is simply an exploration, a gentle holding of fascinating, peaceful thoughts, allowing the mind to have something soft to focus on, something wondrous as it prepares for sleep. And just before we begin our gentle drift, if you find that these quiet explorations help you unwind, if this space we share brings you a measure of peace, perhaps consider a quiet click on the like and subscribe buttons. It's a simple, silent gesture, but it helps other sleepy souls, other explorers, find their way to this little port of calm too. But for now, all of that can fade away. There is nothing you need to do. There is nothing you need to remember. Your only task is to settle in, to feel the gentle pull of gravity, to feel the support beneath you. Let your breath deepen, let your muscles soften. Give yourself permission to let go. Your mind is free to wander, and if it wanders into dreams, that is perfectly all right. Our journey has already begun. 1. The light you see from the Andromeda Galaxy tonight began its journey before modern humans even existed. That faint, fuzzy patch of light, visible to the naked eye in a truly dark sky, is a traveler through time, a collection of photons, tiny packets of light that have been streaming through the silent, cold darkness of intergalactic space. When that light first left its source, our own distant ancestors were just beginning to shape simple tools on the African savanna. It has traveled for longer than our species has been civilized, passing through vast, empty voids just to arrive here, to end its long journey by gently landing in your eye. To look at Andromeda, or M31 as astronomers call it, is to look deep into the past, a snapshot of a city of stars as it was millions of years ago, a quiet, shimmering hello from an incomprehensibly distant time. 2. While our own Milky Way is a bustling metropolis of stars, Andromeda is a true galactic empire. We often feel overwhelmed by the scale of our own galaxy, with its estimated 300 or 400 billion stars, a number so vast it's difficult to hold in the mind. Yet, Andromeda, our gentle neighbor, simply dwarfs us. Current estimates suggest it contains at least 1 trillion stars, a million individual suns. Imagine every single grain of sand on a large, vast beach, and then multiply that by 1,000. You are only just beginning to approach the number of stars burning quietly in this single, spinning island of light. It's a colossal stellar city, so much more populated than our own, with 1 trillion chances for planets, 1 trillion suns warming their own secret worlds, all held together in a gentle, gravitational dance. a city of light so vast it reminds us how wonderfully peaceful the cosmos can be. 3. Our two galaxies, the Milky Way and Andromeda, are slowly, gently drifting towards each other for an eventual embrace. This grand event, sometimes called the Milkomeda collision, sounds dramatic, but the timescales are so vast they are inherently peaceful. The two great spirals are being pulled together by their mutual gravity, closing the 2.5 million light-year gap at a speed of about 70 miles per second. Yet, even at that almost unimaginable speed, the journey will take another 4.5 billion years to complete, a future so distant our own sun will be nearing the end of its life. And when they do finally meet, it will not be a violent crash, but a gentle merging. The spaces between stars are so colossal that individual stars will almost certainly not collide at all. They will simply drift past one another like ships in the night, their orbits reshaped by the new combined gravity, slowly forming a new, even grander elliptical galaxy. A slow, cosmic waltz choreographed by gravity across the ballroom of time. 4. At the very heart of the Andromeda Galaxy lies a beautiful mystery, a bright, central core that appears to be two, not one. For a long time, astronomers were puzzled by this. It seemed Andromeda had a double nucleus, two bright points of light where only one should be. One theory suggested that perhaps a smaller galaxy had been consumed long ago, and its own central core was now trapped in a tight, looping orbit around Andromeda's main supermassive black hole, a cosmic prisoner dancing for eternity. But a more recent and perhaps more gentle idea is that we are not seeing two separate cores at all, but rather a single massive ring of old reddish stars. This ring is not perfectly centered, it is eccentric, and as the stars in this vast tilted disk orbit the true center, they appear to slow down and bunch together at the farthest point of their orbit, creating a brilliant illusion, the shimmering appearance of a second glowing heart, a rhythmic, beating pulse of starlight at the center of a trillion-star system. Like our own Milky Way, the Andromeda Galaxy holds a sleeping giant in its spinning, glowing center. This is its own supermassive black hole, a point of immense gravity from which not even light can escape, a silent anchor for the entire galactic structure. This colossal object, which is hidden from our view by the swirling dust and the glare of a billion stars, is estimated to be substantially more massive than our own, perhaps 100 million times the mass of our Sun, packed into a space smaller than our inner solar system. This is the quiet anchor, the gravitational heart, around which all 1 trillion of Andromeda's stars ultimately dance their long, slow orbits. It is not a hungry monster actively consuming its surroundings, but a still, quiet central point, a place of perfect calm and unimaginable density that sculpted the galaxy's core billions of years ago and now rests silently, dreaming in the center of its own vast starry kingdom. 6. The sheer size of Andromeda in our night sky is an illusion of perspective, as it is vastly larger than it appears. If our eyes were sensitive enough to see its full, faint expanse, the galaxy would appear more than 6 times wider than the full moon. Imagine holding your hand up to the night sky. The moon is a small circle, but Andromeda's glow would stretch far beyond it, a vast, shimmering oval of ancient light dominating the constellation. We only see the very brightest, most central part, the core, with our naked eye. The rest of it, the sprawling, gentle arms, and the vast, diffuse halo, are a secret, painted on the sky in watercolors so faint only long-exposure photographs can truly capture them. It is a quiet giant, hiding its true, magnificent scale in the darkness, waiting patiently to be seen. Andromeda is not alone on its journey through the cosmos. It is the gravitational anchor of a whole family of smaller galaxies. It acts as the gentle, massive center of what astronomers call the local group, a collection of over 50 galaxies, including our own Milky Way. Andromeda is the largest member of this family, the older sibling to our own galaxy. It is attended by at least 14 smaller, dwarf galaxies that orbit it, much like planets orbit a star or moons orbit a planet. Two of its most famous companions, M32 and M110, can even be seen in small telescopes, appearing as tiny, fuzzy smudges clinging close to their enormous parent. It is a portrait of a galactic family, all drifting together through the great dark void. 8. The beautiful swirling arms of Andromeda are places of vibrant, youthful energy. These arms, which are laced with dark lanes of interstellar dust, are the stellar nurseries of the galaxy. This is where vast clouds of cold hydrogen gas, thousands of light years across, slowly collapse under their own gentle weight. As they collapse, they fragment into glowing cocoons where thousands of new stars are born. These young stars, many of which are massive, hot, and brilliantly blue, light up the spiral arms, making them shine with a distinct bluish tint. This is in beautiful contrast to the galaxy's center, which glows with the soft, yellowish light of older, more ancient stars. The arms are the galaxy's rivers of creation, constantly, quietly, turning dust into new suns. 9. The history of our understanding of Andromeda is a story of receding horizons. For centuries, astronomers using telescopes saw this object, but they believed it was a spiral nebula, a cloud of gas within our own Milky Way, perhaps a solar system in the process of forming. It was catalogued by Charles Messier as M31, simply another fuzzy object to be avoided by comet hunters. It was not until the 1920s, a time not so very long ago, that the astronomer Edwin Hubble, using the most powerful telescope of his day, was able to see individual stars within the nebula. By measuring their light, he proved with breathtaking certainty that this nebula was in fact a separate, colossal island universe, a galaxy just like our own. And in that moment, the universe we thought we knew suddenly became billions of times larger. 10. Surrounding the bright, visible disk of Andromeda is a vast, invisible structure known as its stellar halo. This is an enormous, spherical cloud of an entirely different kind of star, ancient and thinly spread, that extends for hundreds of thousands, perhaps even a million, light years in all directions. These are some of the oldest stars in the galaxy, formed in the very distant past, before the beautiful spiral disk had even taken shape. They no longer orbit in a neat, flat plane, but in vast, looping, chaotic orbits like a swarm of silent, glittering bees, enclosing the entire galaxy in a ghostly, spherical embrace. This halo is the galaxy's attic, filled with ancient relics that tell the story of its very first, chaotic days. 11. Within Andromeda's halo, there are ancient, shimmering treasures known as globular clusters. These are magnificent, dense balls of stars, each one a tightly packed sphere containing hundreds of thousands or even millions of stars, all bound together by their own gravity. Our Milky Way has about 150 of these, but Andromeda, being so much larger, boasts nearly 500. Each one is a tiny, ancient galaxy in miniature, a grapefruit-sized cluster of light in the sky if you were close enough to see it. The stars within them are ancient, some of the very first to be born, and they have been orbiting together in a tight, gravitational dance for billions and billions of years, silent, glittering snow globes drifting through the galactic night. One of Andromeda's globular clusters, known as Mayl-2 or G1, is a true behemoth. It is so large and bright that for a long time, astronomers wondered if it was not a cluster at all, but the remnant core of a small galaxy, a dwarf galaxy that had been torn apart by Andromeda's gravity long ago. It is the most luminous globular cluster in our entire local group, shining with the light of millions of suns combined into one point. It is so massive that it may even have its own medium-sized black hole at its center, a rarity for a cluster. It drifts in the outer halo of Andromeda, a testament to a violent, ancient past, now settled into a quiet, shimmering ball of light. 13. The stars in Andromeda's vast, flat disk do not sit still. They are all in constant, graceful motion. The entire galaxy is spinning, rotating like a colossal, glittering pinwheel. But it does not spin like a solid object. The stars farther from the center, in the outer arms, move at a surprisingly fast and constant speed, almost as fast as the stars closer in. This was a deep puzzle, as gravity suggests they should move much slower, like the outer planets in our solar system. This discovery, that galaxies spin too fast for their visible matter, was one of the very first gentle clues that there was something else there, something invisible, a vast scaffold of dark matter holding the galaxy together and guiding its long, slow cosmic spin. The center of the Andromeda Galaxy is a place of ancient golden light. Unlike the youthful blue-white spiral arms, the central bulge of Andromeda is dominated by old, very old stars. These are stars that have been burning for billions of years, long-lived reddish and yellow stars, like our own sun, but much, much older. This central region is a quiet, settled place. There is very little gas or dust left, which means new stars are no longer being born there. It is a galactic retirement home, filled with the soft, warm glow of 1 trillion elderly suns, all crowded together in a beautiful, dense sphere, a silent testament to the galaxy's long and peaceful history. 15. Andromeda is not just a collection of stars, it is also a colossal reservoir of gas and dust. This is the interstellar medium, the raw material from which future generations of stars will be born. This material is not evenly spread, but is sculpted by starlight and supernovae into vast, intricate, and beautiful shapes. There are dark, cold clouds, molecular clouds, where dust grains are so thick they block all the light from behind, creating dark lanes and filaments that look like empty rivers winding through the starry arms. And there are glowing HII regions, where hot, young stars have ionized the gas around them, making it glow a beautiful, faint reddish pink, like cosmic neon signs announcing the birth of new suns. 16. The galaxy of Andromeda is moving toward us, but its sideways motion was a mystery for a very long time. We knew it was approaching, but we did not know if it was on a trajectory for a direct hit or if it would be a glancing blow. Using the Hubble Space Telescope, astronomers spent years minutely tracking the tiny, almost imperceptible sideways drift of stars within Andromeda, a feat of measurement akin to watching a baseball on the moon move by a few inches. Their findings confirmed it. Andromeda is heading almost directly for us. But again, the timescale is so immense, so peaceful, that it is not a threat, but a simple fact of our shared gravitational future, a destiny written in the slow, silent language of orbits. 17. Within Andromeda, astronomers have discovered something fascinating. A massive, rotating disk of stars, not in the galaxy's main plane, but tilted, cutting through the central bulge. This disk of death contains stars that are relatively young, a surprising discovery for a region that is supposed to be old and quiet. The stars in this tilted disk are orbiting the central black hole in a highly eccentric, stretched-out path. It is thought that this structure is the leftover debris from a smaller galaxy, perhaps one that was rich in gas, that spiraled into Andromeda's core a few 100 million years ago. Its stars were stripped and its gas funneled to create this new, strange, and beautiful secondary disk, a ripple in the calm pond of the galactic center. 18. While Andromeda is visible to the naked eye, its true nature was debated for centuries. The Persian astronomer Al-Sufi, writing over 1,000 years ago, in the year 964, described it in his Book of Fixed Stars as a little cloud. It was the first time it was written down, a formal recognition of this strange, hazy patch of light. For the next 1,000 years, it remained just that, a cloud, a nebula. It's a humble reminder that some of the greatest mysteries of the universe, objects of unimaginable scale and power, have been hiding in plain sight all along, waiting patiently for us to build the tools and the understanding to see them for what they truly are. 19. The sheer, flat expanse of Andromeda is almost hard to comprehend. While it is over 200,000 light-years from one spiral tip to the other, making it much wider than our own Milky Way, Its main disk of stars is incredibly thin. On average, the disk of stars, gas, and dust is only about 1,000 light-years thick. If you were to scale the galaxy down to the size of a large dinner plate, its thickness would be less than that of a single sheet of paper. It is a structure of immense, delicate, and breathtaking fragility. 1 trillion stars spinning in a disk so thin it is almost two-dimensional, a shimmering, cosmic platter floating in the dark. 20. The Andromeda Galaxy is a known cannibal, but a very gentle and slow one. Its vast gravitational pull has been drawing in and consuming smaller, dwarf galaxies for billions of years. This is how all large galaxies grow. We can see the evidence of this process in the form of stellar streams, long, faint rivers of stars that have been torn from these smaller galaxies and are now arcing through Andromeda's halo. These are not violent events, but slow, tidal processes, where the smaller galaxy is gently pulled apart, unraveled like a ball of yarn, its stars slowly mixing and merging with the larger galaxy, adding to its mass and its ancient stellar halo. 21. Our first clear photographs of Andromeda in the 19th century caused great excitement, but also great confusion. In 1887, Isaac Roberts, a pioneer in astrophotography, took the first long-exposure image that clearly revealed the galaxy's spiral structure. No one had ever seen such a thing, a swirling pinwheel shape in the heavens. This beautiful image, while a triumph, only deepened the mystery and strengthened the spiral nebula hypothesis. It looked so much like a vortex, a whirlpool, that many scientists became convinced it was a new solar system being born, a sun and planets condensing from a cloud of gas, never imagining it was a city of stars, 1 trillion times larger. In the year 1885, a single new star appeared in the heart of Andromeda, briefly becoming so bright it almost outshone the entire rest of the galaxy. This event, S Andromedae, was the first and only supernova ever recorded in another galaxy. At the time, astronomers had no idea what it was. They thought it was a nova, a much smaller event happening within our own galaxy, but just coincidentally in the same direction as the Andromeda Nebula. It was only decades later, with the understanding that M31 was a separate galaxy, that they realized what they had seen: the catastrophic, magnificent, and final explosion of a massive star, 2.5 million light-years away. The spiral arms of Andromeda are not solid structures like the arms of a pinwheel. If they were, they would wind themselves up and disappear in just a few rotations. Instead, they are density waves. Imagine a traffic jam on a highway. The jam itself, the dense area, moves very slowly, but individual cars are constantly entering it, slowing down, and then accelerating out the other side. The spiral arms are just like this. They are slow-moving waves of higher gravity, waves of compression that sweep through the galaxy's disk. As clouds of gas and dust enter this wave, they are squeezed, just enough to trigger their collapse and ignite new stars, which is why the arms are so bright and blue. The space between our galaxy and Andromeda is not perfectly empty. While we call it the intergalactic medium, it is filled with a very, very thin, almost undetectable fog of ionized gas. But more than that, Andromeda's own vast halo, that spherical cloud of ancient stars and hot gas, extends much farther than we thought. Recent studies show its gaseous halo, a diffuse, invisible atmosphere, stretches for more than 1 million light-years, halfway to our own Milky Way. This means, in a very real, tangible sense, the outermost wispy edges of our two galaxies, their atmospheres, may already be touching, a first, gentle and invisible handshake across the vast, dark quiet. The Andromeda Galaxy has two prominent, smaller companion galaxies, M32 and M110, that are in a slow, orbital dance with it. M32 is a small, very dense and compact elliptical galaxy. It seems to have had all of its outer layers, its fluff, stripped away, likely by a close pass with the main Andromeda Galaxy in the distant past. M110, on the other hand, is a diffuse, dwarf spheroidal galaxy, a much more ghostly and spread-out collection of stars. These two companions, one stripped bare and one a gentle puff of light, tell a story of gravitational interaction, of the different ways a large galaxy can shape and bully its smaller orbiting neighbors over billions of years. The Andromeda Galaxy is actually tipped at a very steep angle relative to our line of sight. We are not seeing it face-on, like a beautiful flat pinwheel, nor are we seeing it perfectly edge-on, like a thin bright line. It is tilted at about 77 degrees, which means we are looking at it from a high oblique angle. This tilt, while making it harder to see the true spiral shape, is what allows us to see the dark, intricate dust lanes so clearly, as they are silhouetted against the bright, golden light of the central bulge. It gives the galaxy a sense of depth and perspective, a three-dimensional grandeur that a simple, flat-on view might lack. 27. If you could drift through the spiral arms of Andromeda, you would find a rich tapestry of colorful nebula. These are the clouds of gas and dust that are the building blocks of stars, and they glow in a beautiful array of colors, though they are often too faint for our eyes to see. Emission nebula, like the famous Orion Nebula in our own galaxy, glow a vibrant red, the color of energized hydrogen gas, as they are lit up from within by hot new stars. Reflection nebula, on the other hand, glow a soft, gentle blue, as they are not hot enough to glow on their own, but are simply reflecting the light of nearby blue stars, like a fog bank illuminated by a bright blue light. 28. The very faintest outermost edges of Andromeda's disk are warped, like a vinyl record left out in the sun. The disk is not perfectly flat. As you move farther and farther from the center, the disk of stars and gas seems to be gently and slowly bent or flared. This warping, which we also see in our own Milky Way, is thought to be a gravitational echo, a lasting sign of a past interaction. It is likely the signature of a dwarf galaxy or a large cloud of gas that was absorbed by Andromeda billions of years ago. And as it was pulled apart, its gravity gently twisted and sculpted the shape of the entire outer disk, a ripple that is still visible today. 29. Because Andromeda is so similar to our own Milky Way, but we can see it from the outside, it is a perfect cosmic mirror. By studying Andromeda, we learn about ourselves. We can see its overall structure, its halo, its stellar populations, and its star formation rates all at once, something we cannot do for our own galaxy because we are stuck inside it. When we look at the Milky Way, it is like trying to understand the shape of a forest while standing in the middle of it. We can only see the nearest trees. But Andromeda gives us an external bird's-eye view of what a large spiral galaxy like ours truly looks like, a beautiful, shimmering reflection of our own galactic home. 30. The speed at which Andromeda is spinning is truly immense. At its outer edges, the gas and stars are orbiting the galactic center at a speed of over 160 miles per second. This is so fast that a single full rotation, a galactic year for those outer stars, still takes over 200 million of our Earth years to complete. This means that since the time of the dinosaurs, the Andromeda Galaxy has only spun around a few times. It is a motion so vast and so slow on a human timescale as to be almost indistinguishable from perfect, peaceful stillness, a giant cosmic pinwheel turning in ultra-slow motion. 31. In the 1990s, the Hubble Space Telescope was pointed at a seemingly empty patch of sky within the Andromeda Galaxy's halo. What it found in that long, patient exposure was not emptiness, but a faint, sparse, and glittering field of old reddish stars. This was the first direct confirmation of the stellar halo, proving that the galaxy was far, far larger than its visible disk. These lonely, ancient stars, drifting in the vast, dark emptiness of the halo, are like hermits living far from the bustling, bright city center, their soft, faint light a whisper of the galaxy's true, colossal scale. 32. The trillion stars of Andromeda are not all the same. They are a vast and diverse population of different ages, sizes, and colors. In the spiral arms, we see the brilliant hot Type O and Type B stars, massive and blue, which burn through their fuel in only a few million years and explode a supernovae. In the central bulge, we see the Type K and Type M stars, cooler, yellower, and redder, like our own sun, or smaller, which sip their fuel and can burn gently and steadily for billions or even trillions of years. The galaxy is a living, breathing ecosystem of stars, a constant, slow cycle of birth, life, and rebirth. 33. Andromeda is a truly massive galaxy, but it is not the most massive type of galaxy in the universe. It is a spiral galaxy, like our own, defined by its beautiful, organized spinning disk. The largest galaxies known are giant elliptical galaxies. These are vast, reddish, and featureless blobs that are thought to be the end product of many, many galactic collisions, including collisions between two large spirals, like the one destined for the Milky Way and Andromeda. These elliptical galaxies are old, quiet, and settled. Having used up most of their gas, they no longer form new stars. They are the universe's great sleeping giants, a possible, distant, and peaceful future for our own local group. 34. Finding the Andromeda Galaxy in the night sky is a quiet, peaceful meditation. On a clear, dark night in the autumn, far from the glare of city lights, you first find the W shape of the constellation Cassiopeia. From there, you follow a line of stars in the neighboring constellation Andromeda until your eyes land on a small, faint, elongated, fuzzy patch. It does not look like much. It is not brilliant or sharp. It is subtle, a whisper of light. But to know that this faint, gentle smudge is a city of 1 trillion suns, 2.5 million light-years away, is a profoundly calming and wondrous thought. 35. The space between the stars in Andromeda is filled with a fine, pervasive dust. This is not like the dust in your home, but is composed of tiny, microscopic grains of carbon, silicates, and ice. These dust grains are created in the atmospheres of old dying stars and then blown out into space in the slow, gentle stellar winds or in the more dramatic supernova explosions. This dust, while it blocks our view and creates the beautiful dark lanes in the spiral arms, is also the very seed from which new things are made. It is the raw chemical ingredient that will one day clump together to form new stars, new planets, and perhaps new life. 36. There is a sweet spot in the Andromeda Galaxy, much like in our own, called the Galactic Habitable Zone. This is a theoretical ring, a cosmic Goldilocks region in the galaxy's disk. In the center, the stars are too crowded, and the radiation from the central black hole and nearby supernova would be too intense. In the far outer edges, the stars are too metal-poor, meaning they lack the heavier elements like iron and carbon that are necessary to form rocky planets. But in between, in a gentle, vast, donut-shaped ring, lies the perfect balance, enough heavy elements and enough peaceful quiet for planets like ours to potentially form and thrive. 37. The supermassive black hole at the center of Andromeda, M31 star, is currently in a state of deep, quiet slumber. Its immense gravity, 100 million times that of our Sun, is not actively feeding on large amounts of gas and dust. If it were, it would become an active galactic nucleus, or a quasar, flaring up and blasting out jets of high-energy radiation that would light up the entire galactic core. But Andromeda's center is peaceful. The giant is sleeping. The flow of gas into the center has slowed to a mere trickle, and so the heart of this trillion-star galaxy beats with a soft, gentle, and steady glow. 38. The Andromeda Galaxy is a magnificent blue shift galaxy, which is a cosmic rarity. When we look at almost every other distant galaxy in the universe, they are all redshifted. This means their light is stretched out to longer, redder wavelengths because the fabric of space itself is expanding, and they are all moving away from us. But Andromeda is blue shifted. Its light is compressed to shorter, bluer wavelengths. This is the simple cosmic Doppler effect that tells us its own motion, its own gravitational pull towards us, is overriding the expansion of the universe, and it is one of the very, very few galaxies that is gently, peacefully getting closer. 39. The great spiral arms of Andromeda are not the only place new stars are being born. The Hubble Space Telescope was surprised to discover a vast, diffuse ring of star formation far, far out in the galaxy's disk, a place that was thought to be quiet and empty. This outer ring, which is over 100,000 light-years from the center, is dotted with clumps of young, blue, hot stars. One theory is that this ring is a cosmic ripple caused by a smaller galaxy, perhaps M32, punching directly through the disk of Andromeda, like a stone dropped in a pond, creating an expanding, circular wave that is now, 2 billion years later, triggering a new, unexpected, and beautiful ring of birth. If you could stand on a planet in the outer halo of the Andromeda Galaxy, the view would be breathtaking. You would be surrounded by the sparse, faint, ancient red stars of the halo, glittering in the darkness. But below you, or above you, filling half of your sky, would be the magnificent, shimmering, golden disk of the galaxy itself. A colossal, spinning, silent pinwheel of 1 trillion stars, with its bright central bulge and its intricate, blue-dusted spiral arms, all laid out before you like a map of heaven. It would be, perhaps, the most beautiful and profoundly peaceful sight in the entire universe. 41. Our own sun, our star, is currently on a long, slow, 230 million-year orbit around the center of our Milky Way. In the 4.5 billion years since the collision with Andromeda is predicted, our sun will have completed that orbit about 20 more times. And when the galaxies do merge, our sun and its family of planets will almost certainly be completely fine. The spaces between stars are simply too vast. Our sun will not be destroyed. It will not be thrown out of the galaxy. It will simply find its orbit, gently, slowly altered, as it joins a new, even larger stellar family, settling in to a new path in a new, grander Milky Galaxy. 42. The local group, the family of galaxies that includes the Milky Way and Andromeda, is not standing still. This entire collection of over 50 galaxies is itself moving through the universe as a single, gravitationally bound unit. We are all drifting at a speed of over 1 million miles per hour towards an even larger supercluster of galaxies known as the Virgo cluster. And that cluster is being pulled towards an even larger great attractor. It is a beautiful cosmic dance of scales from moons to planets to stars to galaxies to clusters, all moving, all drifting, all held in a silent, gravitational, cosmic rhythm. 43. The Andromeda Galaxy has a much larger central bulge, that bright, golden central sphere of old stars, than our own Milky Way does. Our galaxy is thought to be a flatter spiral with a more modest center and perhaps more prominent, tightly wound arms. This difference in structure, the bulge-to-disk ratio, tells astronomers a different story of formation. It suggests that Andromeda, in its distant past, may have had a much more violent or active history of merging with other large galaxies, which helped to puff up and build its enormous, ancient central core. 44. When we look at Andromeda, we are seeing it in all different wavelengths of light, not just the visible light our eyes can detect. When we look in infrared light, we see the gentle, warm glow of cosmic dust, dust that is warmed by starlight. And this light shows us where the cold, star-forming gas is hiding. When we look in ultraviolet light, we see only the very hottest, most massive, and youngest blue stars as they burn with a fierce, brilliant light. This view shows us exactly where new birth is happening. And when we look in X-ray light, we see the most energetic and violent processes, like black holes feeding or the super hot remnants of exploded stars. Each view is a different layer of this magnificent cosmic city. 45. The Great Andromeda Nebula, as it was known for so long, was the subject of a great debate in 1920. Two prominent astronomers, Harlow Shapley and Heber Curtis, argued publicly about the nature of these spiral nebulae. Shapley argued that our Milky Way was the entire universe, and that Andromeda was just a small gas cloud inside it. Curtis argued that Andromeda and the other spirals were island universes, just like our own, and that the universe was incomprehensibly vast. At the time, the debate was a draw. There was not enough evidence. It was only 3 years later that Edwin Hubble provided the final, quiet, and definitive proof that Curtis and the island universe was the correct and wonderful answer. 46. The total viral mass of the Andromeda Galaxy, which includes all the stars, the gas, the dust, and the invisible dark matter, is truly staggering. It is estimated to be over 1 trillion, and perhaps as many as 2 trillion times the mass of our Sun. It is a gravitational mountain in the fabric of space-time. This immense and mostly invisible mass is what holds all 1 trillion of its stars in their long, slow orbits. It is the silent, unseen shepherd that keeps the entire glittering flock from drifting apart into the long, dark, intergalactic night. 47. In 2012, astronomers made a surprising discovery about Andromeda's many small, dwarf satellite galaxies. They found that nearly half of them were orbiting not in random, chaotic paths, as was expected, but in a single, vast, thin plane, like planets orbiting a star. This plane of satellites is a deep puzzle, as our current models of galaxy formation and dark matter suggest this should be very, very unlikely. It is a quiet, cosmic anomaly, a piece of the puzzle that does not quite fit, a gentle reminder that this beautiful, neighboring galaxy still holds deep and peaceful mysteries that we have yet to understand. 48. The most common type of star in the Andromeda Galaxy, just as in our own, is a star we cannot even see. These are the red dwarfs, small, dim, and incredibly long-lived stars. They are less than half the mass of our Sun, and they burn their fuel so slowly and so efficiently that their expected lifespan is not billions, but trillions of years, longer than the current age of the universe. The galaxy is filled with these faint red embers, burning quietly, gently, and almost eternally in the background, the true, silent, and enduring population of this vast stellar city. 49. Andromeda is so bright and so large that it has been a testbed for astronomy for over a century. Because it is our closest, large neighbor, it is the first place we look when we get a new, more powerful telescope. It was where we first proved the existence of other galaxies. It was where we first studied Cepheid variable stars, the standard candles that allow us to measure the vast distances of the cosmos. It has been a Rosetta Stone, a patient, cosmic teacher that has, time and time again, unlocked the next great, quiet secret of the universe, just by floating peacefully in our night sky. 50. The beautiful spiral structure of Andromeda is a grand design spiral. This means its arms are long, continuous, and well-defined, wrapping elegantly around the galactic center. This is in contrast to flocculent spirals, which have more patchy, fluffy, and fragmented arms, like our own Milky Way is thought to have. The grand design is thought to be created by the gentle, persistent gravitational nudging of its companion galaxies, like M32 and M100. Their orbits stirring the disk and creating the massive, beautiful density waves that sculpt the gas and dust into such a perfect, magnificent, and peaceful spiral form. 51. The Andromeda Galaxy is not just a visual spectacle. It is also a source of faint, cosmic radio waves. When astronomers point radio telescopes at M31, they don't see the stars. Instead, they see a map of the interstellar gas and the synchrotron radiation that is created by high-energy electrons spiraling around the galaxy's magnetic fields. This radio glow traces the spiral arms in a different kind of light, revealing the galaxy's invisible magnetic skeleton. It's a different kind of sound from the galaxy, a low cosmic static, a whisper that tells a different story, a story of magnetism and cosmic rays zipping silently through the vast, cold spaces between the stars. 52. In the far distant future, after our own sun has become a white dwarf, and after the Milky Way and Andromeda have long since merged, the new giant elliptical galaxy, Milkomeda, will continue its journey. It will drift through the local group, which itself may have condensed, and over trillions and trillions of years, as the universe continues to expand, all other galactic superclusters will recede beyond the cosmic horizon, moving away from us faster than the speed of light. Eventually, our Milkomeda galaxy will be the only thing left in our observable universe, a single, vast, quiet island of old red stars floating alone in an endless, perfectly dark, and peaceful eternal night. 53. The dust lanes in Andromeda, those beautiful dark filaments that trace the spiral arms, are more than just shadows. They are, in a very real sense, the galaxy's circulatory system. These lanes are vast, dense rivers of cold gas and dust, the raw material for new stars. This material is constantly in motion, flowing from the outer galaxy, slowly, gently, spiraling inwards towards the center. As it flows, it is processed, it is compressed in the density waves, it is enriched with heavy elements from exploding stars, and it is then finally reborn as new generations of stars and planets, a slow, cosmic cycle of renewal, painted in dark, beautiful strokes against a canvas of starlight. 54. If our eyes were sensitive to X-rays, the Andromeda Galaxy would look very different. Instead of a soft, glowing spiral, we would see a collection of brilliant, pinprick point sources. These are the most energetic and often the most violent objects in the galaxy. We would see X-ray binaries, where a normal star is orbiting and being eaten by a tiny, dense black hole or a neutron star. And we would see the glowing, expanding supernova remnants, the superheated, million-degree spherical shells of gas left behind by stars that exploded thousands of years ago, a ghostly, high-energy after-image of a life lived fast and brightly. 55. The name Andromeda comes from Greek mythology. She was a beautiful princess who was chained to a rock by the sea as a sacrifice to a sea monster. She was saved by the hero Perseus, who is immortalized in a neighboring constellation. And so, when astronomers long ago named the constellations, they placed this entire royal mythological family in the same region of the sky. Andromeda, Perseus, his mother Cassiopeia, and her father Cepheus all have constellations that wheel around the sky together with that faint, fuzzy little cloud resting forever in the princess's constellation, a cosmic and poetic coincidence. 56. The very first photograph of Andromeda's spectrum was taken in 1899. A spectrum is when you pass light through a prism and break it down into its rainbow of constituent colors. This is a fingerprint of light that tells you what an object is made of and how it is moving. That first primitive spectrum of the galaxy's bright central core looked surprisingly like the spectrum of our own sun. It was not a simple glowing gas cloud. This was a critical early clue that this nebula was not a nebula at all, but was made of something far more complex and familiar. It was made of stars. 57. The Andromeda Galaxy is surrounded by a vast, hot, and almost invisible atmosphere of gas, sometimes called the circumgalactic medium. This is a massive halo extending for over 1,000,000 light-years, filled with a super thin, super hot plasma, gas heated to millions of degrees. This halo is thought to contain as much mass as all the stars in the galaxy combined. It is the galaxy's fuel tank. Over billions of years, this hot gas will slowly cool and rain down onto the galaxy's disk, providing a gentle, steady supply of new hydrogen that will fuel the birth of stars for billions and billions of years to come. While our Sun is a solitary star, many of the stars in Andromeda are born and live in pairs. These are binary systems, two stars locked in a mutual gravitational waltz. Some are visual binaries that we can see as two distinct points of light orbiting each other. Others are eclipsing binaries, where one star passes in front of the other from our point of view, causing the combined light to dim in a regular, rhythmic pulse. The galaxy is filled with these dancing pairs, from massive, bright blue stars to tiny, dim red dwarfs, all locked in a silent cosmic partnership. 59. The globular clusters that drift in Andromeda's ancient halo are like fossils of the galaxy's birth. The stars within them are all almost the same age, and they all formed from the same original cloud of gas over 12 billion years ago. This means they are time capsules from the very, very early universe. By studying the chemical makeup of these ancient stars, astronomers can read the history of the universe itself. They can see what the cosmos was made of in those first, pristine, early moments, long before our own sun or our Earth had even begun to form. 60. The supermassive black hole at the heart of Andromeda is orbited by a strange and beautiful disk of young blue stars. This was a complete surprise, as the immense tidal forces so close to a black hole should have torn any gas clouds apart before they could collapse to form stars. The current best and most gentle idea is that a single large molecular cloud, perhaps 100,000 times the mass of our Sun, wandered too close. It was torn apart, but its own immense internal gravity was just strong enough to hold it together as it was stretched into a ring that then, and only then, fragmented into a string of brilliant blue stellar pearls. 61. There is a specific kind of star called a Cepheid variable that is like a cosmic metronome. These stars are not steady, but naturally pulsate, getting brighter and then dimmer on a very, very precise and regular schedule. And the speed of their pulse is directly related to their true brightness. This is the standard candle that Edwin Hubble used. He found these pulsing stars in Andromeda. He measured their pulse rate, which told him how bright they really were, and by comparing that to how dim they appeared, he could calculate the distance, a simple, elegant, and galaxy-shattering piece of cosmic arithmetic. 62. The Andromeda Galaxy has more heavy elements than our own Milky Way, especially in its central regions. In astronomy, metals are anything heavier than hydrogen and helium, all the carbon, oxygen, iron, all the things that make up planets and life. These elements are forged inside the hearts of massive stars and then released when those stars explode. The fact that Andromeda's core is so metal-rich tells us that it had a more active youth, a faster, more intense period of star birth and star death in its distant past, which rapidly enriched its gas with the building blocks of new and interesting worlds. 63. If you were to look at Andromeda in the far infrared, you would see a galaxy glowing with a different kind of light. This is not starlight, but the cold, gentle heat re-radiated by the galaxy's dust. The tiny, microscopic dust grains absorb the hot, blue ultraviolet light from young stars, and they get gently warmed up. They then re-radiate that heat as a faint, far infrared glow. This cold light is the best way to trace the cold clouds, the places where new stars are just on the verge of being born. It is a map of the galaxy's hidden potential. 64. The Andromeda Galaxy is often overexposed in popular photographs. To capture the faint outer arms, the central core gets blown out into a solid white glare. But in reality, the dynamic range of the galaxy is immense. The core is intensely, blindingly bright, a dense, packed sphere of 1 billion old golden stars. And the outer arms are incredibly, ethereally faint, a subtle blue dusting on a black canvas. To truly see Andromeda with your eyes would be to see this incredible, peaceful contrast between the blazing, ancient heart and the whispering, youthful edges. 65. The Andromeda Galaxy is the target of many microlensing surveys. This is a clever and patient way of looking for dark or dim objects. If a dark object, like a planet or a dim red star, or perhaps a small primordial black hole, passes exactly in front of a more distant background star, its gravity will act like a lens, a magnifying glass, and for a few brief hours or days, it will bend and brighten the background star's light in a very specific and predictable way. It is a way of finding the unseen, the dark things that drift silently through the galaxy. 66. The dark matter halo that surrounds Andromeda is not a smooth, perfect sphere. According to computer simulations, it should be clumpy. It should be filled with thousands of smaller subhalos, little invisible nuts of dark matter that are the leftover, unmerged remnants of all the small dwarf galaxies that Andromeda has consumed over its long billion-year life. These invisible ghosts are still orbiting within the larger halo, their gravity silently and gently tugging on the stars that passed by, a vast, unseen, and complex cosmic sculpture. 68. Our journey to Andromeda, a 4.5 billion-year collision, is not the end of the story. The local group itself, which is dominated by Andromeda and the Milky Way, will eventually merge. The smaller galaxies will spiral in and be absorbed, and over 100 billion years, or more, our entire local family of 50 or 60 galaxies will have coalesced into one single, colossal, and final giant elliptical galaxy, a quiet, reddish supergalaxy, the last grand construction in our little local corner of the cosmos. The Andromeda Galaxy has a twin, a sister galaxy called the Triangulum Galaxy, or M33. This is the third largest galaxy in our local group. It is a beautiful face-on spiral, but it is much smaller and fluffier than Andromeda. It is not a grand design spiral, but a flocculent, patchy spiral, bursting with bright pink star-forming regions. M33 is currently orbiting or interacting with Andromeda, and it is possible that its gravity is what helps to stir up and create the beautiful long spiral arms in its much, much larger neighbor. 69. In 2015, astronomers using the Hubble Space Telescope were stunned to find a hypervelocity star being ejected from the Andromeda Galaxy. This is a star moving at over 1 million miles per hour, so fast that it is unbound. It is escaping the galaxy's immense gravity. The only thing that could throw a star this hard is the supermassive black hole at the galaxy's center. This star must have been part of a binary pair that wandered too close to the giant. Its partner was captured and consumed, but this star was slingshotted and thrown with incredible peaceful violence out into the long, dark intergalactic night. 70. The bulge of the Andromeda Galaxy, that bright central golden sphere, is not a simple round ball. When studied closely, it has a distinct peanut or boxy shape. This is a telltale sign. This shape is the signature of a galactic bar, a vast, elongated structure of stars orbiting in the center, but seen from an end-on or tilted perspective. This bar acts like a funnel, channeling gas and dust from the inner spiral arms down towards the central black hole, a slow gravitational conveyor belt that feeds the very heart of the galaxy. 71. There are stellar streams in the halo of Andromeda that are so vast they have names. The giant stellar stream is a colossal, faint river of stars that was undoubtedly once a small dwarf galaxy that was shredded by Andromeda's tides. By studying the color and age of the stars in this stream, astronomers can reconstruct the history of this ghost galaxy. They can tell what it was made of and when its final, fateful encounter with Andromeda began. It is a form of galactic archaeology, reading the gentle ruins left in the sky. 72. If you could smell the Andromeda Galaxy, what would it smell like? In the dense molecular clouds, the vast, cold nurseries where stars are born, astronomers have detected the faint chemical fingerprints of polycyclic aromatic hydrocarbons, or PAHs. These are complex organic molecules, the same basic compounds that on Earth create the sooty or barbecue smell of smoke. And in the vast, cold, dark clouds, they find ethyl alcohol, the same as in spirits. The space between the stars is a vast, cold, and surprisingly complex cosmic chemical factory. 73. The Andromeda Galaxy is not its only name. Its catalog number is Messier 31, or M31. It is also NGC 224. Charles Messier was a French comet hunter in the 1700s. He was frustrated by all the faint, fuzzy objects in the sky that looked like comets but were not comets. They stayed in one place. He created his Messier catalog as a list of things to ignore. And in a beautiful cosmic irony, his list of nuisance objects has become a greatest hits list of the most beautiful and profound deep sky wonders in our universe. 74. The star formation rate in Andromeda is surprisingly low. Despite its trillion stars and vast reservoirs of gas, it is in a semi-retired state. It is only creating about one new sun-sized star per year. Our Milky Way is much busier, creating perhaps 3 to 5 new suns in the same amount of time. This tells us that Andromeda is a more mature galaxy. It peaked long ago. It had its active youth and is now settling into a long, quiet, and peaceful middle age, a gentle giant slowly going to sleep. 75. The light echo of the 1885 S Andromeda supernova has been found. Even though the explosion itself faded in a few months, its light is still traveling. A few years ago, Hubble looked at the gas clouds in the vicinity of where the explosion happened, and it saw those clouds faintly glowing from a reflected light. It was the original flash of the explosion, now arriving at those clouds over 130 years later and illuminating them, a ghost of a ghost, an echo of a star that died long ago, still whispering in the dark. 76. The Andromeda Galaxy is a template for our own future. By studying its large central bulge, its red and dead old stars, its metal-rich core, and its low star formation rate, we are seeing a picture of what our own Milky Way will likely become, even before the collision. Our galaxy is still in its active spiral phase, but in a few billion years, it too will calm down, its gas will be used up, and it will slowly transition from a blue, active galaxy to a red, quiet one. Andromeda is simply further along on that same peaceful path. 77. The interstellar medium, the space between the stars in Andromeda, is not a vacuum. It is a thin soup of particles. For every cubic centimeter of space, a space the size of a sugar cube, there is on average only one single atom. This is an emptiness so profound, it is 10,000 times more empty than the best vacuum we can create in a laboratory on Earth. And yet, because the galaxy is so vast, this almost nothing adds up to billions of suns worth of mass, a thin fog that is still the stuff of creation. 78. The Triangulum Galaxy, M33, Andromeda's little sister, may be on its first pass. Calculations of its orbit are complex, but one intriguing possibility is that this fluffy spiral is not in a stable orbit at all. It may be a newcomer to the Andromeda system, just falling in for the very first time. This would explain why it is still so unscathed and why it is having such a dramatic starburst of activity, its gas shocked and ignited by its first gentle gravitational brush with its new colossal neighbor. 79. The oldest stars in Andromeda, in its halo and its globular clusters, are chemically simple. They are almost purely hydrogen and helium, the two elements created in the Big Bang. They have almost no metals, no carbon, no oxygen, no iron, because when they were born, 12 or 13 billion years ago, no other stars had yet lived and died to create those elements. They are pristine first-generation, or second-generation, stars, a pure sample of the baby universe, still shining quietly today. 80. The rotation curve of Andromeda is flat. This is the smoking gun for dark matter. In our solar system, the planets slow down the farther they are from the Sun. Mercury moves fast, Neptune moves slow, because almost all the mass is in the center. In Andromeda, the stars do not slow down. Stars in the outer arms move just as fast as stars in the inner arms. This is a violation of gravity unless the visible galaxy is just the tip of the iceberg, unless it is embedded in a colossal invisible sphere of dark matter, whose gravity is holding on to those outer stars and speeding them up. 81. The blue loop stars are a puzzle in Andromeda's center. The bulge is supposed to be old and red, but when Hubble looked deep into it, it found a sprinkling of young, hot blue stars. This was a contradiction. The answer is subtle. They are not young at all. They are blue stragglers, reborn stars. They are old stars in binary systems that have collided and merged, or old stars that have siphoned new hydrogen fuel from their companion. They look young on the outside, but it is a borrowed youth, a gentle cosmic deception that makes the old heart of the galaxy still twinkle with blue light. 82. The magnetic field of Andromeda is organized. Like its spiral arms, its magnetic field lines also seem to spiral around the galaxy in a ring or torus shape. This invisible structure is threaded through the gas clouds, and it guides the flow of charged particles, cosmic rays, through the galaxy. It is a vast, galactic magnetic shield, a structure as real as the stars themselves, just unseeable to our eyes, a silent force field that shapes the entire ecosystem of the galaxy. 83. The Andromeda Initiative was a fictional story element in a video game, Mass Effect. It told a story of explorers being sent to the Andromeda Galaxy in cryosleep to find a new home. It is a beautiful science fiction idea that captures our imagination because Andromeda is the only other great galaxy that we can see with our own eyes. It is not just a scientific object, it has become a cultural one, a symbol of the farthest shore, the ultimate destination, a dream of intergalactic wandering. The M31 globular cluster system is different from ours. Not only does Andromeda have more, 500 versus our 150, but they are spread out differently. Our Milky Way's clusters are highly concentrated towards the galactic center. Andromeda's clusters are much more gently, diffusely spread out all throughout its vast halo. This again whispers of a different history, a history of accretion, a history of gently collecting and consuming many smaller galaxies and keeping their globular clusters as trophies of its conquests. The star Pi Andromedae is not in the Andromeda Galaxy. It is a foreground star in our own galaxy in our own backyard that just happens to lie in the same direction as the Andromeda constellation. It is a bright, beautiful blue-white binary star system only a few hundred light-years away. It is a gentle reminder of perspective. When we look at the night sky, we are looking through a window that is dusted with our own local stars, and we are peering out through them at the deep cosmic ocean that lies beyond. 86. The Andromeda Galaxy is bright enough to be seen from moderately light-polluted skies. You do not need a perfectly dark, pristine mountaintop. Even from a suburb, if you know where to look and you let your eyes adapt for 10 or 15 minutes and you use averted vision, looking slightly to the side of it, that faint, fuzzy smudge will pop into view. It is a quiet hunt, a reward for patience, the most distant object a human eye can ever hope to see unaided, waiting for you just beyond the edge of the light. 87. The dwarf spheroidal companion M110 is unusual. It is small and diffuse and fluffy like a ghost. But unlike most dwarf spheroidals, which are old and dead, M110 has signs of recent, in cosmic terms, star formation. It has dark dust clouds and a sprinkling of young blue stars near its center. This is a puzzle. It is possible that its close orbit with Andromeda is triggering the small gasp of new life, its own gas sloshing around and collapsing, protesting its slow, inevitable merger with its giant neighbor. The Andromeda Galaxy is so large that it bends light. Its colossal mass, mostly its dark matter halo, warps the fabric of space-time around it. This gravity lens distorts our view of the galaxies that are billions of light-years behind it. By measuring that tiny distortion, that warping and stretching of the background galaxies, astronomers can weigh Andromeda. They can calculate its true mass, not from the light we see, but from the gravity we feel. A silent, invisible scale for a silent, invisible giant. The supernova rate in Andromeda is higher than ours, per star, but its star formation rate is lower. This sounds like a contradiction. But there are two types of supernovae. The Type 2 core collapse supernovae come from young, massive stars, and Andromeda has fewer of these. But the Type 1a thermonuclear supernovae come from old white dwarf stars in binary systems that steal mass and explode. Because Andromeda has a much larger, older population of stars, it has more of these slow-burning fuses waiting to go off, a different kind of cosmic firework that prefers old, quiet neighborhoods. 90. The dust lanes in Andromeda are clumpy. They are not smooth rivers. They are beaded, fragmented, and stringy. This is because the gas inside them is not uniform. It is constantly being stirred up and pushed around by the stellar winds of young stars and the shock waves from old supernovae. These dark clouds are a turbulent, chaotic battleground of pressure and gravity, which is exactly the violent cradle that is needed to squeeze clumps of gas tight enough to ignite and form a new peaceful star. 91. The search for exoplanets, planets outside our solar system in Andromeda, is almost impossible. The stars are simply too far away. We cannot resolve a single star well enough to see its light dip from a transiting planet. But in 2009, a candidate was found using microlensing. A background star brightened in a way that suggested the lens was not just a star, but a star with a planet. It is P99-9N2, a single potential extragalactic planet, a tiny ghost of a world drifting in a galaxy 2.5 million light-years from home. 92. The Andromeda Galaxy is older than the Milky Way, in a sense. The evidence suggests that Andromeda formed faster and earlier. It grew quickly by merging with large galaxies very early in the universe's history. This built up its large bulge and ancient halo rapidly. The Milky Way seems to have had a quieter, gentler childhood, growing more slowly and steadily over time. Andromeda is the older sibling that matured quickly, while our galaxy took its time. The color index of Andromeda is a soft yellowish white. This is the average color of all 1 trillion of its stars blended together across space. The blue light from its young spiral arms mixes with the golden reddish light from its old central bulge. The result is this pale, creamy golden glow, the true color of this island universe, a gentle, warm hue that speaks of both youth and ancient age simultaneously. 91. The Andromeda Galaxy is not perfectly spiral. Its arms are disturbed. One arm seems to be pulled out and warped, and there are spurs and bridges of gas that don't fit. This beautiful imperfection is almost certainly the gravitational signature of its companions. The tiny M32 galaxy on its plunging orbit, or the larger M33 on its distant pass, are constantly tugging at the disk, gently pulling at the threads and disrupting the perfect symmetry, creating a more complex and living structure. 99. The future merger, Milkomeda, will trigger a magnificent starburst. The 2 galaxies, both rich in gas, will collide and their gas clouds will slam into each other, compress and ignite a frenzy of star formation. For a few 100 million years, the new merged galaxy will blaze brilliantly with the light of billions of new blue stars, a final glorious celebration, a cosmic renaissance, before all the gas is used up and the new galaxy settles down into its long, quiet red retirement. 100. And finally, the name Andromeda itself means ruler of men or mindful of man. It is perhaps a beautiful accident of language that this colossal city of stars, this deep cosmic neighbor that so captures our imagination and humbles our spirit, carries a name that ties it back to us. It reminds us that we are not just observers of the universe, we are a part of it. We are the part that can think and wonder and give names to the light, a small local consciousness, drifting peacefully in the face of the vast and silent infinite. The light from Andromeda is a composite, a chorus of 1 trillion voices singing in harmony. When we look at that faint smudge, we are not seeing one thing, but the blended, smeared-out light of 1 trillion individual suns. It is the pale, ancient, golden light of 1 billion old stars in the central bulge, mixing with the sharp, brilliant, youthful blue light of the millions of new stars being born in the spiral arms. It is the glow of red giants, the shine of white dwarfs, and the faint shimmer of countless red dwarfs, all traveling for 2.5 million years, their individual voices lost, but their combined chorus, their collective glow, arriving here as a single, soft, and peaceful patch of light in our night sky. 102. There are likely trillions of rogue planets drifting in the cold, dark, lonely spaces between the stars in the Andromeda Galaxy. These are planets just like Jupiter or even Earth that were formed in a solar system but were then ejected, thrown out by a complex gravitational slingshot interaction with their larger sibling planets. They now drift in the endless, silent, dark, unwarmed by a sun. Their surface is frozen, their oceans, if they have them, locked under miles of ice. The galaxy is, most likely, filled with these lost worlds, a silent, invisible shadow population of planets that we will never see, each one a self-contained, frozen capsule of a solar system that once was. 103. The vast, flat, spinning disk of Andromeda is a place of delicate balance. It is a battleground, but a peaceful, slow-motion one. The force of gravity is constantly, gently, trying to pull all the gas and dust clouds together to collapse them into new stars. But the forces of energy, turbulence, magnetic fields, and the pressure from new stars blowing out winds are pushing back. The entire galaxy disk exists in this gentle equilibrium, this slow cosmic dance between collapse and expansion, birth and energy, which is what allows it to calmly simmer and form stars steadily for billions and billions of years. 104. The center of the Andromeda Galaxy is a place of extreme crowding. In the central bulge, the stars are packed incredibly tightly. If you were on a planet there, the night sky would be unimaginable. It would not be dark. It would be a blazing canopy filled with thousands of stars as bright as our planet Venus, or even brighter. A sky so filled with golden light that true darkness would never fall. It would be a perpetual, gentle twilight lit by a million ancient suns, a truly wondrous and peaceful place to be. 105. The eventual merger of the Milky Way and Andromeda will be a magnificent, creative, and gentle process. While the stars themselves will drift past each other without incident, the vast, diffuse, and cold gas clouds that float in each galaxy's spiral arms will not be so lucky. These clouds, which are the fuel for star birth, will collide violently, slamming into each other at hundreds of miles per second. This colossal collision will create shock waves that will compress the gas like a thunderclap, triggering a frenzied burst of star formation, igniting billions of new suns in a final, glorious blaze of creation before the gas is all used up and the new galaxy settles into a quiet old age. 1-1. That will be a galaxy that is red and dead, a vast, ancient, and peaceful cosmic retirement home glowing softly with the light of trillions of ancient suns. 119. The Triangulum Galaxy, M33, is the third point of this cosmic dance. It is currently orbiting Andromeda, or perhaps just falling in for the first time. Its own fate is tied to ours. It will likely not collide with us directly, but will spend the next few billion years in a long, looping orbit around the merging Milky system, before it too is finally pulled in and its own stars are gently added to the new supergalaxy billions of years from now. 120. The light from Andromeda is a ghost. It is not the light of the galaxy as it is right now, tonight. It is the light of the galaxy as it was 2.5 million years ago. In the time that light has been traveling to us, the galaxy itself has lived and breathed and changed. 2.5 million new stars may have been born. Thousands of stars have exploded as supernovae, and the entire galaxy has spun on its axis and drifted ever closer. We are looking at a postcard from the deep past, a beautifully preserved snapshot of a time before humanity even walked the room. 121. The search for life in Andromeda is a question of pure imagination. We cannot detect it. We cannot go there. But with 1 trillion stars and countless trillions of planets, it is a beautiful and peaceful thought. Somewhere in that faint smudge of light, there are other suns shining on other worlds. There are rocky planets in habitable zones with liquid water and the same carbon and oxygen that we are good of. The galaxy is a vast field of potential, a trillion chances for something wondrous to take hold and to look back in wonder. 122. The magnetic fields of Andromeda are like a cosmic shield. These vast, invisible lines of force that spiral through the galaxy's disk help to protect it. They channel and deflect high-energy cosmic rays that come streaming in from deep space. They help to support the gas clouds, preventing them from collapsing too quickly. They are an unseen skeleton, an invisible weather system that gently guides the galaxy's energy and helps to create a stable and peaceful environment for stars to be born and live. 123. The speed of the stars in Andromeda's halo reveals its mass. By finding individual bright stars or globular clusters in the far outer reaches and measuring their speed, astronomers can play a simple game of gravity. The faster that star is moving, the more gravity, more mass must be inside its orbit, holding on to it. And these outer stars are moving shockingly fast, far faster than the visible stars and gas can account for. This is the clearest, most peaceful proof of the immense invisible halo of dark matter that surrounds the entire galaxy. 124. The star M31RV1 was a star that fooled us. For a time, it was thought to be a hypervelocity star, one ejected from Andromeda's core and speeding towards us. But further study revealed the gentle truth. It was not a visitor from another galaxy at all. It was a very rare, old and fast-moving star from within our own Milky Way's halo that just happened to be in the same patch of sky. It is a calm reminder that the universe is full of coincidences and that our own backyard is full of surprising and ancient things. 125. The halo of Andromeda is full of ghosts. As it has torn apart and consumed dozens of smaller dwarf galaxies over billions of years, the stars from those galaxies are not instantly mixed. They linger for a time in long, faint streams and clumps, orbiting like the ghost of their former selves. The Andromeda halo is not smooth. It is lumpy and filled with these stellar streams, a visible record of its long and gentle history of galactic cannibalism. 126. The very first time a human recognized Andromeda as a fuzzy star, we do not know. The Persian astronomer Al-Sufi was the first to write it down in 964 AD, calling it a little cloud. But it is visible to the naked eye. For tens of thousands of years before that, humans on dark, clear nights must have looked up and pointed at that strange, faint smudge, a permanent cloud that never moved. They would have invented myths and stories for it, never once dreaming it was a trillion other suns, a wondrous secret hiding in plain sight. This thinness is what allows the spiral density waves to move through it so efficiently, like ripples on a shallow pond, gently squeezing the gas and dust to form new generations of stars. 128. The companion galaxy, M32, is a cosmic oddball. It is a tiny, compact elliptical that is plunging on a close orbit around Andromeda. It is like the pit of a peach. It is thought that M32 was once a much larger spiral galaxy, but a close pass with Andromeda long ago stripped away all of its outer arms and halo, leaving only its dense, burnt-out core behind to continue its long, lonely dance. 129. The stars in Andromeda are not silent in radio waves. While most normal stars, like our Sun, are very quiet, there is a class of star called a pulsar. This is the tiny, super-dense spinning corpse of a massive star that has exploded. As it spins, it shoots out beams of radio waves from its poles, like a cosmic lighthouse. And if that beam sweeps past Earth, we hear a perfectly regular pulse. Pulse, pulse. Andromeda is filled with these tiny cosmic metronomes, thousands of them beating their silent rhythm across space. 130. The light of Andromeda that reaches us is profoundly diluted. The inverse square law of light is a powerful and gentle truth. A star that is twice as far away is 4 times dimmer. A star that is 10 times farther is 100 times dimmer. Now imagine a galaxy that is 2.5 million light-years away. The combined blaze of 1 trillion suns is so thinned out by that unimaginable distance that it arrives here as nothing more than the faintest, most delicate smudge of light, visible only to a dark-adapted eye, a true testament to the scale of the void. 131. The central bulge of Andromeda is not a sphere, but a peanut. When astronomers look at the motions of the stars in the core, they don't move as if they are in a simple ball. Their orbits trace out a more complex, boxy or peanut-like shape. This is the telltale sign of a galactic bar, a vast, elongated river of stars that rotates like a solid object in the galaxy's heart. We are seeing this bar not from the side, but tilted away from us, giving us this strange and beautiful perspective. 132. The atmospheric seeing is what blurs our view of Andromeda. Even with the largest telescopes on Earth, the individual stars of Andromeda smear together. This is because our own planet's atmosphere is a turbulent, rippling ocean of air. It is like trying to look at a pebble at the bottom of a fast-moving stream. This is why the Hubble Space Telescope, floating above that air in the cold stillness of space, is the only instrument that can provide the perfectly calm and sharp view needed to see the individual stars of our neighbor galaxy. 133. The Andromeda Galaxy is a place of profound silence. There is no air in space to carry sound. The explosions of supernova that outshine a billion suns, the birth of new stars in crushing gas clouds, the slow, majestic spin of the entire disk, all of this happens in a perfect, absolute, and total quiet. It is a silence so deep and so vast that it stretches for 200,000 light-years across. The entire galaxy is a silent movie, a soundless ballet of gravity and light. 135. The interstellar medium, the stuff between the stars, is a cosmic recycling plant. Stars are born from cold gas clouds. They live their lives for millions or billions of years, fusing hydrogen into heavier elements like carbon and oxygen and iron. Then, at the end of their lives, they gently puff off their outer layers or explode in a supernova, scattering those new heavy elements back out into the gas clouds. This enriches the clouds, which then collapse to form the next generation of stars and planets, a slow, gentle cycle of birth, death, and rebirth. 135. The Andromeda Galaxy is tilted just right for us. At an angle of 77 degrees, it is not perfectly face-on, which would make its spiral arms beautiful, but would hide its depth. And it is not perfectly edge-on, which would show us its thinness but would hide all of its spiral structure in a single line of light. At this tilted angle, we get the best of both worlds. We can see the bright central bulge, we can trace the spiral arms, and we can see the dark dust lanes silhouetted against the core, a perfect three-dimensional portrait. 136. The dark matter halo of Andromeda is like a cosmic scaffolding. We cannot see it, we cannot touch it, it does not interact with light. But its immense gravity is what formed the galaxy in the first place. It was the invisible ocean of gravity that pulled in the first hydrogen and helium gas from the early universe, a gravitational seed, a vast unseen mold that all the shining, beautiful matter that we can see simply settled into, like dust, in a vast invisible bowl. 137. The future Milky Galaxy will have a crowded sky. Our sun will likely be flung out of its current orbit into a new long looping path in the new giant halo. From a planet orbiting our sun in that distant future, the sky would be unrecognizable. The Milky Way band would be gone, replaced by a vast spherical glow of trillions of stars in all directions. There would be no dark patches, no spiral arms, just a deep, profound, and gentle ocean of golden starlight filling the heavens. 139. The globular clusters of Andromeda are like cosmic snowflakes. Each one is unique. While they are all ancient and dense, they have different sizes, different concentrations, and slightly different chemical fingerprints. Some are so dense their cores have collapsed into a knot of stars. Others are more diffuse and spread out. Each one is a little time capsule, a fossil of the early universe that tells its own small, gentle story of its birth 13 billion years ago. 140. The star M31 V1 is a special star. This was the very first Cepheid variable that Edwin Hubble identified in 1923. He found this star on his photographic plates, a star that was pulsing in brightness. By measuring its rhythm, he could calculate its distance, and he realized it was 1 million light-years away, far outside the Milky Way. That single star, that faint rhythmic pulse in a faint patch of light, was the key that unlocked the entire universe and showed us how truly vast and wonderful it all is. 141. The gaseous halo of Andromeda is like a vast atmosphere. It is a bubble of super-hot, thin gas that extends for over 1 million light-years, stretching halfway to our own Milky Way. This halo is the galaxy's fuel tank. Over billions of years, this hot gas will slowly cool and condense and gently rain down onto the galaxy's disk, providing a slow, steady drizzle of fresh hydrogen that will fuel the birth of new stars for billions of years to come. 142. The Andromeda Galaxy is a place of cosmic calm. Despite the supernovae and the black hole, the overwhelming state of the galaxy is one of stillness and emptiness. The distances between stars are so vast that if the sun were a grapefruit in New York, its nearest neighbor would be another grapefruit in Chicago. The galaxy is almost entirely empty space, just dusted with these tiny, isolated pinpricks of light floating in a profound, peaceful, and silent void. 143. The color of Andromeda's bulge is a soft, yellowish gold. This is the color of old age. The massive, hot, blue stars that burn bright and die young are all long gone from this region. All that is left are the long-lived stars like our Sun or smaller, K-dwarfs and red dwarfs that sip their fuel and glow with a gentler, warmer, redder light. The golden glow of the bulge is the combined light of 1 billion ancient suns in their long, peaceful retirement. 144. The spiral arms of Andromeda are a beautiful illusion. They are not solid structures that rotate like a pinwheel. They are density waves, a slow-moving traffic jam of gravity. Stars and gas clouds are not trapped in the arms. They move into an arm from behind, get slowed down and compressed, which triggers new star birth, and then they pass out the other side into the clear space between the arms. The arms are just the places where the traffic bunches up and all the bright young stars flash into life like cosmic neon signs. 145. The Andromeda Galaxy is the most distant object you will ever see with your unaided eye. Everything else you can see in the night sky, every star, every planet, the Milky Way itself, is part of our own local galaxy. But that one faint, fuzzy patch of light is something else. It is the only object visible to your eye that is truly external, truly intergalactic. It is a bridge for your senses, a tiny portal that connects your own small personal world to the unimaginable vastness of the cosmos beyond. 146. The iron in your blood, the calcium in your bones, the carbon in your muscles was not made in the Big Bang. It was forged in the heart of a massive star that lived and died billions of years ago. The same is true for Andromeda. That galaxy is also a great recycling plant, full of the same elements. The laws of physics and chemistry are universal. The processes that create stars and planets and life here are the same processes happening in that faint smudge of light 2.5 million light-years away, connecting us in a deep and elemental way. 148. The Andromeda Galaxy will not always be in our sky. In a few billion years, as it gets closer, it will grow larger and larger and more magnificent, a fiery streak across the night, as it merges with our own Milky Way. And then, in the far, far distant future, trillions of years from now, as the universe continues to expand, all other galaxies will have fled beyond our cosmic horizon, receding faster than light. Our Milkomeda Galaxy will be the only thing left in a perfectly empty, black, and lonely universe, the last island of light in an eternal night. 148. The act of looking at Andromeda is an act of time travel. The light that hits your eye tonight left that galaxy 2.5 million years ago. When that light began its journey, our ancestors were not yet human. There were no cities, no language, no fire. You are seeing the light from a profoundly ancient past. And, in that same moment, any potential observer in Andromeda looking back at us with a powerful telescope would not see us. They would see the Earth as it was 2.5 million years ago. It is a gentle bridge of light connecting two deep and distant pasts. 149. The Andromeda Galaxy is a reminder of perspective. It is a colossal city of 1 trillion suns, each one a potential solar system. It is so vast that our minds cannot truly grasp its scale. And yet, it is only one of an estimated 2 trillion other galaxies in the observable universe, most of which are drifting away from us so fast we will never see them. It is a profoundly humbling and peaceful thought to feel so small and yet to be a part of something so impossibly grand. And so, we see that this faint cloud, this smudge of light in the constellation of a chained princess, is not a single object at all. It is 1 trillion stories happening all at once. It is a place of birth with new stars igniting in blue fire in the spiral arms. It is a place of ancient age with 1 billion old suns glowing golden in the core. It is a place of profound mystery, held together by an invisible scaffolding of dark matter. And it is a place of our own future, a silent dance partner drifting gently closer to us across the vast ballroom of space. And so, our gentle journey to that far shore of the cosmos draws to a close. We have drifted on currents of thought across an ocean of 2.5 million light-years to visit that great shimmering island of light. We have wandered through its trillion stars and felt the immense, peaceful scale of its silent arms. We have considered the light that traveled longer than our species has existed, just to land softly in our minds tonight. We have floated past ancient globular clusters, those glittering balls of ancient suns. We have traced the dark dust lanes, the rivers of creation, where new stars are quietly being born. And we have contemplated the great silent merger, a destiny written in gravity where our own Milky Way and this great neighbor will one day gently embrace and become one new vast city of light. You are a part of this story. The atoms in your body, the iron, the carbon, the oxygen, were forged in the heart of a star, just like the ones we have visited tonight. You are made of stardust, looking back at the stars. And as you lie here, settled and warm, you are drifting on a small blue planet that is itself sailing through a vast spiral arm of our own galaxy. You are already a traveler on this cosmic ocean. But for now, the journey is over. There is nothing left to do, nothing left to see or think about. Your mind has wandered far, and now it deserves to rest. Let all these thoughts of trillions of stars and vast distances simply dissolve into a feeling of profound calm and deep stillness. Let the vast, peaceful silence of intergalactic space fill your room and your mind. It is time to let go. It is time to drift into your own peaceful dreams. May your sleep be deep and restorative. May you dream of silent galaxies and shimmering light. Good night.